To kick off, so good afternoon everyone, and thanks for joining our latest webinar in the Tales and Tech Live series. I'm Simon Evans and I head up the software engineering team here at Burn Sheehan. This afternoon I'm really excited to introduce Josh Smart, who is a senior software engineer at Depop. He has a really great story to tell about how he and a few friends were made redundant and put their talent and newfound time to good use. He's happy to answer any questions at the end, so please use the Q&A function available. So here's Josh with serverless migration and the Cheapskates guide to hosting a product. Over to you, Josh.
Thanks. So hi, my name's Josh. I'm a senior software engineer at Depop, like Simon said. So a few months ago when Simon asked me to do this, obviously it's called Tales in Tech. So I was kind of like inspired to make it a bit of a story of how a few friends and I during lockdown decided to work on a product basically. I'll just share my screen quickly. So yeah, basically, I'll start it off. So the story starts with basically a few friends and I were working on a little tool, kind of like going on in the background, which was a gamification tool for software engineering teams, and basically, just a forward as well. Sorry for any kind of like shameless marketing because I will do it. But the story starts out basically by me working on a proof of concept for a gamification tool. And it's ended up being called gamify.team. So I'll quickly go through kind of like the concept of what the product is. But imagine you've got a team made up of Will, Josh, and Joe. We've got obviously these software engineering teams, we use tools like GitHub and Jira. And when we use these tools, there's certain actions that you want people you want to encourage people to do certain actions, and you want to discourage people to do certain actions as well. So let's say I create a new Jira issue, and I create an issue without a description. Obviously, that's something that you kind of want to deter. So I'll lose 10 points. If Joe comes along a few minutes later and basically leaves a comment on a pull request, and obviously that's something you want to encourage. It's obviously collaboration on a pull request. It's something that's good. And then a few minutes after that, Will merges a pull request, and obviously a good thing. We want some work to be done. So that's the kind of like basis of the product. But basically, the origin of the product was actually implemented 2 past jobs, where it was basically a gamification tool that was only integrated with GitHub or the equivalent tool, and basically it was exactly the way what I showed you. The teams got rewarded points when they were doing certain things good on GitHub, and instead of when I saw it being made on those two past jobs, when I was about to make it a 3rd time, I thought, let's make it so that we don't have to actually remake it each time, and hopefully build a product where other teams in other companies can actually start using. So basically, I started building something just kind of like in my spare time, and the original tech stack for that one was I wanted to be running in Docker. It was microservices written in Kotlin, hosted using ECS, and an RDS Postgres database. So just one sec. And so I didn't really think about the costing of how much this was going to cost, because it was just kind of like the tech stack I was used to, just worked on it. And I was using a free tier AWS at this point. So a quick breakdown of what this service looked like at this point. There were 3 services. One was a GitHub integration service. One was a very partially complete service that was about GitHub integration. And there was one other service that was for handling all things like data, like CRUD requests. So like logging in, creating teams, and just basically a bunch of half-done features. And then on top of it, there was a front-end application that was written in React. It was hosted on Netlify. So basically, this thing was just bobbing around away in the background. And when the free tier finished on AWS, I basically turned it off. And I hadn't really thought about it. Just like most side projects, they kind of just eventually go nowhere. So I was just bobbing around, didn't go anywhere. But then basically April hit. And we, just like everyone, COVID definitely had an effect on everyone. It's the reason why we're doing a webinar versus seminar at the moment. Plus some executive criminals at the company I used to work for decided to steal a bunch of money. And a lot of my friends were made redundant. So at this point I had, and so did my friends, have a lot of spare time. It was a grim outlook in getting another job because the market was pretty fucked. And we also weren't allowed outside, which didn't really deter us that much, being software engineers anyway. So like I said, we had a bunch of spare time. So me, my friends, Joe, Will, and Steve, we decided that we'd do something productive, and it means try and learn something and basically just do something productive with our time. So basically we decided, we had a few ideas, but we eventually all agreed that we'd start working on the gamification tool that I'd previously started looking into. So what we decided to do, we looked at what we had already, and there was a bunch of kind of half-done features. There were, GitLab integration. There was trophies where if you do a certain few actions, then you get trophies. All these things were kind of like half done. And if we actually implemented them all, it was just, we were never going to get there. So we decided to use the most possibly overused and cringy term in the industry, which is we decided to productionize and build an MVP. So the MVP that we agreed to start working on was, well, the features of the MVP, I should say, were basically two integrations, Jira and GitHub, a web app, which was going to have like basic login functionality, inviting people to your team, and then a leaderboard, which would basically show when certain users, like where they are on the leaderboard, and then also notifications on the web app, which would mean when someone leaves a comment, the leaderboard is notified and you see basically the action in real time that's happened. So, one sec. And basically we looked at the architecture that we already had as well. And obviously we didn't want to keep bolting onto the existing services. We wanted to make microservices. We wanted to kind of like do everything right. But we also looked at the price that it was going to be to host this service, the way it was originally intended. And we looked at the costs, and it was for 3 small EC2 instances, it was going to be about $40 a month. And then for the database, it was going to be close to $50 a month, and that's not including like the actual storage. And keep in mind, this is like 3 small EC2, 3 T2 small EC2 instances don't handle too much load. So if we did get a few more, if we made a few more microservices, or we got a decent amount of load, we were going to have to scale, and it was going to be expensive. And also a really important thing here is, if we were to scale using these tools, it's complicated to figure out how to scale properly, and it's also expensive. So, and like I said, we didn't have jobs, so we were basically very cheap at this point. So we thought about what we could do to fix this, and the obvious solution was going serverless. So I'll go through the costings for it later. But basically this is the architecture that we ended up having. Obviously it didn't look this polished originally, but we were using Terraform, which meant that as our architecture changed, it was very easy for us to change the infrastructure. So you basically just made some changes, and it was very easy to, it was just very easy to keep things consistent from what our designs were from what was actually in AWS. So it looks complicated, but I think regardless of the tools we were using, when you're using microservices, it's always it looks fairly maybe intimidating for some people, but it's basically just different ways that the services are going to be communicating with each other. So the tech we ended up using was Cognito, API Gateway, SQS, Dynamo DB for a NoSQL database, and AWS Lambdas. I'm not sure if I mentioned those already, and Cognito. So these tools, they're built to be used together, which is a super important thing. So it was very easy for us to integrate with them, and And like I'll talk about later, it was also very cheap. And they're also like just very good tools, which I'll go into more detail later about. So I'm going to go into more detail about the details of the architecture. So I'll quickly go into the plugin architecture. So this is basically how we handle when a user, I'll go through the scenario. So if we've got a team that uses GitHub and Jira, what they'll do is they'll use the webhooks within GitHub and Jira. They'll generate a link within gamify.team. They'll link it to their GitHub or Jira. And then when certain users do certain things like create a comment, add a PR, blah, 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 what'll happen is the webhooks will hit API gateway. I'll talk about authentication authorization in a bit, but we can forget about for now. So what'll happen is the API gateway will basically convert that REST request or HTTP request into an SQS message, and then pass that message on to the appropriate Lambdas. Those Lambdas will convert the message. So let's say this message is saying, Josh added a comment. We'll convert that to whatever the appropriate points are, and then save that in Dynamo DB. So these Lambdas we wrote in Kotlin, and one of the downsides to having a Kotlin Lambda is the performance is quite it's slow. There's lots of reasons why it's slow, but yeah, they're slow. And what we did to fix that, because this was an asynchronous process, we didn't like the webhooks didn't really care about the response. It was just like once they send it to us, it was just fire and forget kind of thing from their perspective. We decoupled those responses by basically translating that message to an SQS message. So API gateway will just basically straight away respond, and then the Lambdas will process those messages independently. So something that, because obviously this is about what I wanted to kind of talk about is the migration. So I think the best place to start if you are wanting to do a serverless migration is definitely something with an asynchronous process, because if you've written an application in Java that's say like a batch application, then it shouldn't be too much effort to move it into a Lambda, because one, you can have it, you don't need to worry about performance, which it won't be great. Yeah, so if you're doing an asynchronous process, Lambdas in Kotlin are fine, but they are slow. So the next thing I'm going to talk about is the CRUD architecture. And I'll focus a little bit here on the authentication and authorization. So Cognito, for any of you who don't know, is basically, it allows you to, it's kind of AWS's version of us being able to create users and handling a login process for them. So they have an endpoint where you can create users, you can have an endpoint where you log in, and the response from that endpoint will be a token, like an authorization token, or I think it's called an access token. So inside that access token, it'll have information about what type of user it is, what type of user this person is, and certain other attributes. So in this example, we'll have the team being team 456. So what'll happen is the client will use that access token to authenticate with API gateway. Then API gateway, because we've configured it to go to a custom-made auth Lambda, and this Lambda was written in Node, so it's very quick. And what'll happen is this Lambda will take that token, figure out this data, so like, is it a super user, is it a team, and then respond back to API gateway if that user can, what resources that user can access. So it'll basically say this person has access to post get team 456. If they do a put, for example, then API gateway will then respond appropriately with like a 403. So that's the authentication. The next thing is the thing is, sorry, the CRUD Lambda, like I said, this one was also written in Kotlin, and it is very slow, which is something that's a bit of a problem for us at the moment. But because a lot of the endpoints with our products, they weren't necessarily going to be synchronous processes. So basically, the team just has a leaderboard on there. Those are all WebSockets. Those are all WebSocket calls to, and there's very few actual real-time requests. So we basically focused on other things. So yeah, I think if we were to redo things, I would definitely encourage writing things in either Python or Node, just because they're small and they're easy, and they're fast. So like I said, I won't go into detail about the WebSockets, but basically we had WebSockets to notify the front end app when certain actions happen. So say someone creates a pull request, we'll notify that front end that web app that someone has done that, and that the way that works is using WebSockets. So obviously forecasting the usage of a product is very hard. So this is by no means a science. It's just kind of just some numbers that we picked just for the sake of comparing the cost between how we were going to host it and how much and how we do host it at the moment. So let's say we've got 100 teams with 10 people. Each team has an active WebSocket. So this is like they've got the leaderboard up there and they're actively listening for notifications coming back. And each team integrate. So we've got 1.4 million connection minutes every month. That's the equivalent of how much time people are actually looking at it. And each team integrating with both GitHub and Jira, which let's say it is 50 activities per hour. And that's basically 4 million messages a month coming to our Lambdas. Sorry, my Slack's not on mute. 1 sec, sorry. I don't know why it's not working. Anyway, so an uneducated estimate of 1 million requests per month just for plain old calls. So those are the CRUD ones. And just for the sake of comparison, 50 gigabytes a month storage. So like I said, that's just like a random selection of data. Let's go through the actual pricing for the tools that we were using. So Cognito, there's 50,000 monthly active users are free a month. So I think we were pretty safe. I think if we got more than that, I think we'd be happy. I don't think we'd be sad that we'd have to start paying for it. With Dynamo DB, you get 25 gigabytes free storage, and then 25 cents per gigabyte per month after that. 2.5 million reads. I won't go into detail about this one, but basically you pay per read and write, or pay per million read and writes. Then Lambda, you get 1 million requests free. You get 217 hours of compute time. Don't ask how I got these numbers, but you can trust me, I guess. So and another thing is the API gateway. You get a bunch free. Sorry, you've got to pay for basically the connection minutes and how many messages are coming through. And then of course SQS, you get 1 million free messages, and then it's I don't even know how many decimals that is, but it's pretty cheap per message. So how much was this actually going to cost us? Obviously Cognito, again, sorry for how many numbers I'm throwing at you, but Cognito was going to be free. If we were going to compare Dynamo DB then to RDS, basically Dynamo DB was going to cost $16 versus $48 using RDS. Lambda, it was really hard to figure out how much usage we were going to get from this Lambda, but it's undoubtedly cheaper to be using Lambda versus anything. And I'll talk more in a bit about the scaling. So API gateway, it's going to cost $2. SQS might as well be free. So I think one of the main important things here is that this is the cost that we were going to have to pay AWS. But I think a really significant thing here is the cost of scaling. Scaling, and I've said it already, the scaling is coming for free. So because the scaling is coming for free, the amount of effort that it would take to figure out how to scale an application if it wasn't hosted this way, I think would just be quite significant. And I think that's pretty important for any size company. If you're saving money through operations, then it's a benefit. So I kind of like have gone on a bit of thing there about the cost and everything, and I'll quickly kind of go through how we actually got the product. So after we decided the architecture was going to be like that, obviously it wasn't always that polished, like I said, but basically we worked for 3 months on it, on and off, while applying for jobs, trying to actually get employed. We then all got jobs, and I think we're about a month into our jobs where we were like, we need to just release this thing. So we finished up and we released it, and we've obviously been busy with our jobs in the meantime. We've got a bunch of upcoming features that we're kind of just doing on the side every now and then, but really it's just sitting there waiting for people to start using. And funnily enough, we didn't use it for about like us ourselves. We didn't because we as an engineering team, we were actually using our product ourselves, and we actually hadn't been working on it. So last night we checked to see, when I do this demo in a few minutes, if it actually still worked, and surprisingly it did work. And the reason for that is one of the reasons, at least, because you're not having to worry about a server running. AWS is handling all this thing. There's nothing running. We've told it when something happens, run. There's no like service that stopped running. So it's just always there. So one of the main, like I said, one of the most important thing is the scaling. It takes a lot of time and money to do right, and we're getting it for free. Dynamo DB, Lambda, and Gateway. If we did become successful, it would just scale. We don't have to worry about it. And like I said before, the amount of time and effort that you're saving doing this, not worrying about the scaling, is savings for any size team. And like I said, the operational costs might as well be zero. Extra learnings, basically just don't write lambdas in Python, and like in Kotlin or Java. It's slow. There's things that you can do to get around it, like layers, which means that, won't get into it, but that's one way that you can fix it. There's a few others, but it's just complicated, and it's just I'm a Java fanboy, and I unexpectedly really enjoyed writing these lambdas in Node. So I'll quickly go into a demo. So I'm hoping that Joe is on the call, and what he's going to do is we've got a pull request open here. He's added a comment, but what we should do is I'll log in. This is our leaderboard, and what will happen is, Joe, do you mind adding a comment now? We should see in a few seconds, basically Joe getting some points and a notification saying exactly what he's done. So yeah, obviously he added a comment on GitHub. I can show you the comment. Obviously he got some points. There we go. So yeah, that's that in use. If I want to quickly go through a few other things, there's basically the plugins that we've got at the moment. We've got GitHub, we've got Jira, and what you do is you just copy this if you've created a team, and you just add this into your webhooks in the appropriate tool. So that's the demo. That's pretty much it. The last thing is, if you're in engineering teams, we're really keen to get some feedback on this. The service is free, so just sign up if you like it. Let us know what you think, and that's it. Thanks.
Perfect. Well, Josh, thank you very much for that. That was extremely informative and very interesting. There is a question for you straight away on the Q&A part. So from Ben, how well formed was the architecture for the MVP? The MVP, do you mean when we started working on it, or once it was done? Because this is basically what the architecture ended up looking like and looks like at the moment, within probably about a month and a half or so. So the only thing that really changed, like
the premise of using SQS to communicate between asynchronous Lambdas, and obviously for each new plugin, just adding an extra one here. Sorry, I'm not showing my screen. Basically, yeah, it was basically the same as that picture I was showing you, which I'll share my screen again. It was basically just this, minus a few Lambdas. And I think there's another question, which is how does serverless architecture compare with server-based solutions when scaling applications with high volume, high performance considerations? So it depends on the scenario. So how does architecture compare? So I think basically the main problem is you don't have to worry about it. I'm not quite sure I understand the question, but you don't have to. If there's high performance needs, then AWS can take care of it. They know what they're doing, and you can obviously configure these Lambdas to show how many things can be, how many of those Lambdas can be running concurrently, and obviously that's going to cost money, but it just takes away so many of the things that you just don't have to worry about. And as far as performance, it depends on when you say high performance, how high performance. So if it's just like a web-based application, if it's like trading, then I'm not exactly sure how. I think it would obviously, you'd have that scenario would probably be you'd probably have to investigate a little bit more into. Can't really answer that one. And then I got another one from Joey Joe Junior Shabadoo. How much has this cost you in total so far? I think it's cost. I think we accidentally started spamming a bunch of SQS messages for some reason, and I think it ended up costing us like £1 or something like that. So not much. Yeah.
Brilliant. Any more questions there from the audience? Okay, well, Josh, thank you very much for that. As I say, that was great. Good to see that you put your downtime into good use and talent as well. So thanks to everyone for joining us on this webinar as well. It's been great. Of course, we are always keen to hear from our community about any ideas if you want to present like Josh has, or if you've got any wishes that what you want to hear about, please let us know or speak to our community lead, Becca. But yeah, thanks very much, Josh. Say thanks again, and thanks. Yeah, we'll be seeing you soon.
Bye.